We're here at CES 2017. We're actually leaving the convention center. We're leaving it in a Prius that's been equipped really like no other. Nico,
Hi.
You are with a company that makes the technology that allows a car like this, or allows an OEM to make a car that becomes self-driving. Why don't you tell us what we're looking at with all these camera screens here in front of us, these screens?
Yeah, so our company is called AImotive, and the approach that we're taking is vision-based. So what you're seeing here is 6 cameras, 2 cameras pointing to the front, and then 4 cameras providing a surround view of the car.
And so this is something that has been developed fairly recently, right? I mean, why don't you tell us a little bit about your efforts and when you started?
Well, we started in July 2015, so the company is 1.5 years old. We're currently already 125 people, so it's been a rapid growth, both from a technical perspective and growth perspective. But it's been really a fun ride. Our average age is 26. Adam here is driving. He's a good representation of the guys we have working for us.
And really, you don't need to have them driving other than the state rules here, right?
Correct. So it's pretty tricky for a startup like us to get driving permission. So you have to comply to quite many different rules and have driver pull systems in place. So we're getting there step by step.
Before we go into what we're looking at, I do want to mention, or have you mention about some of the backers, some of the folks that you are working with. You have some pretty big names.
Yeah, we were initially we are a VC-backed company, but we have some interesting names behind us. So Bosch VC Group was one of the initial founders. NVIDIA is also one of the founders behind us.
And that's important because a lot of their technology is powering some of these cars, and you're very complementary to that. Why don't you talk, there's kind of 3 layers I think you mentioned of technology that you're involved with to make this reality.
Yeah, so what I'm going to demo here today is the software that is in the car. So we have, back in the trunk, we have a game type of PC. We're not worrying about power consumption. It has NVIDIA graphics cards in it, and it's processing basically this input. So this input plus GPS, basic GPS, is all the data we need to do autonomous driving, even in a complicated environment like this. Secondly, we are providing all of the tools in order to create software like this, and we're also working quite a bit on trying to develop high-level hardware design that would actually help to process this with much lower process power than what we're using currently here.
And I want to talk about that in a moment, but first, let's talk about what's happening as we're driving. We're starting to creep up here to Desert Inn Road. I see a taxi in one. I see a post office truck. It's kind of scary.
Oh, yeah. So this is kind of the first view I would like to show you. So this is the car actually recognizing the objects around the car. So you see the green area here, it's the drivable road surface, it's recognizing the sidewalk, it's recognizing cars. If you would have somebody walking next to it, we would be recognizing the people as well. And this next screen is a very interesting one. In this one, I'm using one camera pointing forward, and with this camera view, I'm able to show the depth, so the distance. For example, this car that is now getting quite far ahead of us, we are able to do this depth-based view from one camera, which means we can also deploy it easily for the surround view and get a nice, accurate map of objects and how far they are around the car.
That map of the objects and the map of what is there in a fixed position becomes kind of important, right? How do you work with that data?
It's super important. I mean, the first thing to crack is to understand where is the car, what are the objects around it, and this segmentation view that I was showing. This is the first step that you need to do. You need to be able to recognize objects reliably, being able to classify. Now we're seeing some pedestrians here as well. I'm switching to a fusion view. This is an interesting view. This is showing bounding boxes of these objects. You're seeing the distance that I was showing, small graphical representation there as well. We're recognizing speed limit signs, traffic signs. These are all the visual cues that you would be needing if you are driving or when you're driving as a human. And that's exactly what we are trying to replicate here. So we want to have a car that you can drop basically anywhere. It will be able to drive somewhat like a human would be in an unfamiliar environment, not necessarily in a safe fashion, but in a scalable fashion. And then when you retrain the car to recognize the environment, you get autonomous driving without having to change the infrastructure.
And you're feeding this information back, and we saw some of it in the screens in the demo room, so you can actually do further simulation and help other cars, right?
Yeah, that's another one. So we have been recording this view, and based on this view, we have generated artificial environment, a 3D model, basically a game engine of exactly the same space around the convention center. And in this virtual space, we can actually have our car drive, and we are replicating this camera input. The car doesn't know it; it's not seeing cameras; it's seeing artificially created sceneries, and we can control the artificial cars and the pedestrians and start testing stuff that would be tricky to test in real life. For example, what happens if there's an accident in front of the car, or if there would be suddenly snow in Las Vegas. Might happen, but very tricky to test in real life if it's not the case when you're actually testing.
Well, and that's huge, because I remember several months ago, 6 months ago or so, Rand, I think, came out with a report saying you couldn't possibly drive and test all the conditions with autonomous cars if you actually had to physically drive, right?
Yeah, that's exactly right, yeah. And the simulation testing is really for the motion part, so how does the car behave? I think you still need to test the recognition part with real life data, because the world is so complex. It's very hard to generate in a reliable fashion.
So from a kind of next steps, one of the things that you mentioned is these high-level tools that you've developed that can be further integrated into ICs, and it seems like cost and power reduced. Why don't you talk to that?
Yeah, so currently the game PC that we're using in the back of the trunk, which is providing now this view from the 6 camera input, it's using roughly 1 kilowatt of energy at the moment, which is quite a lot, and especially cars becoming more electrical than fuel driven, you want to actually use the power to drive instead of doing the segmentation. So we've been working quite a bit on a generic artificial intelligence accelerator, which will, once it's ready on the market, will be able to reduce the power that we're seeing here today with a factor of 20.
That's huge, and it seems like it opens it up for other applications beyond just the automobile.
Yeah, it's a scalable solution. It's a generic AI accelerator. It scales down to smaller devices as well, so we're actually pretty excited about it. So hopefully we'll see it also in other applications than just cars.
And I would imagine too, it probably takes some of the pressure off the need to be connected to the AI, or to a cloud to do AI processing. Is that a correct assessment?
That's correct. Yeah. So the traffic, the stuff happening in traffic like this, it's so fast, and we believe that all of the processing needs to happen in the car. And connectivity is of course good to relay back if something special happened and get that data out there. But for a self-driving car, we believe that it's very important that the car can drive without connectivity in place.
So when we come to a rest and you're there, how much how much data do you need? How much transfer time do you need to transfer the data that you've collected to the home base station or whatever, and off to the cloud?
That's a lot of data. So what we do is we train at our office. So we collect this type of data, including if you have a LiDAR system or a radar system in place, that data as well. And then we have to kind of annotate, label the data so that we know in the data what is a car, what is a person, what is a bicycle driver in the data, so that we have reliable data for training purposes, so that we don't train the AI with wrong data.
I was always wondering about that, how if the machines are teaching the machines, you want to make sure that they have the right input, right?
Yeah, we do want to verify any software release pretty well with the high number of test cases, different situations before we release it to the car. So at the moment we are not learning while we are driving.
And so there's also, you touched upon the idea of sensor fusion. Here we're just using the cameras, but what are your thoughts on using other inputs, LiDAR, radar, etc.?
Well, I mean, kind of visual first approach is a nice scalable approach. It simulates the human driving pattern, but of course you have to be able to do it in a safe fashion. So using radar data, using LiDAR data will actually give you a comfort of double checking stuff. So I can double check, I'm going to show you now the stereo-based dual camera traditional computer vision depth view. And with a LiDAR, I could, for example, easily check the distance to the upcoming car.
It gives you a little depth and maybe resolution you wouldn't have otherwise.
Exactly. So it's really increasing the safety by using as many inputs as you can.
And it really becomes much better than a human could ever do because you can do things, you can see things that a human can't, right?
Exactly. You can see further. You can see in darkness. Actually, with those technologies, even with special cameras, you can see much better than a human can.
Well, and I guess we'll be seeing some of this technology in some major brands soon at some level. I don't know if you can talk to that, but it's pretty exciting, it sounds.
Yeah, the partner we can talk about is Volvo. So Volvo has this Drive Me project ongoing, and that's something we are delivering software to. But there are numerous talks with different OEMs, and hopefully we will end up on the streets sooner than later.
Excellent. Well, it looks like we've come to the end of this ride, so I really appreciate your time, Nico, and good luck with this project as you go on.
Thanks.